Good morning, everyone. Happy Friday. Good morning. Um, it is we're getting close to being able to get back to the ecosystem project, and I was just sort of thinking throughout this week, like what I want to test, like what I want to look at with specs before I like sort of jump back in, and I have these questions remaining still, which is how many entities can we get on a screen before we have performance issues? Uh, and what optimizations can we try to but keep the code still readable? I haven't really been like thinking too much about that. I know ECS already is an optimization, so maybe there's like just different ways of us thinking about the code. I also want to try out the dispatcher that's available in specs, and that would allow me to like basically run some threads every single frame to try to like you know parallelize. Oh man, I can never pronounce parallelize properly. Just my mouth doesn't create the words right. And then of course I want to compare Legion to Specs because that's something we learned about from Amethyst, that they're switching to Legion. And I looked at their repo and they claim to be extremely fast, even faster than Specs. So might be worth something to look into. As a reminder of what we did last time, let's go ahead and run this. We've got three entities: one that has movement, one that sort of two that don't, and then they can eat each other. So I thought that was pretty cool. Also, that other one, it got deleted, so it's not even there anymore. So now I'm kind of gonna like move away from the entire eating thing. Since we know how to do that, we can instead move on to just having a ton of these on the screen. So here's my thought. It's going to be wild chaos, but I'm going to start a small circle in the center of the screen. We're going to give it a random velocity, so just moving around in a random direction. And then we'll give it a collision detection with the edges of the walls so that they stay in and they just sort of bounce around. And then we'll just keep on adding until we decide not to. So that's the idea that I think. Okay, so and we want to like actually display what we have. So we have position, size, color. I think this is all fine. Velocity, grow by. I don't think we're gonna need grow by anymore. That being said, it doesn't really hurt it to register grow by. We're just not going to use it. And here we have world, and we're just creating these three. So I'm gonna actually delete these, and we're gonna sort of start over with that. And I guess the question is like, what other things do we want? Do we need to keep track of? And we have the context here, so we can even create meshes in this this one. Viable clan member, good morning. I'm a bit quiet. When I'm talking, I'm going into the yellow. I'm not peeking into the red. So I'm not sure if I want to like raise the volume too much more. Is your volume like really high up and it's still really low? I think it's this one. I can turn this up. Oh, it was you. Okay, don't. I was about to change the gain on the mic, and that would probably brought me into the peaking territory. All right. So let's see. So we have that. So we're gonna add some like walkers. We'll probably just start with one in the middle. This is also going to get us into dynamically adding sort of the entity territory. Okay, so we have our systems. We're going to change this out. We're not going to run our systems manually like this. I want to use I mean, maybe we will like to begin with, and then we'll optimize by moving to a dispatcher. And then we have our everything here like this. So I want to start with a system that's going to display text, display the number of frames per second that's happening. So GGEZ will give us the frames per second, but it's averaged out over the last 200 frames. So it's not like a clear, like, you know, this is exactly what it is, but I think it's close enough. If we really wanted to get that, we could like take the duration between each frame and calculate that ourselves. I think that the frames per second calculation they're going to give us is going to be fine for this. We already have this render system. So we could add on to Hue, but what I'm thinking of is I want to add maybe a UI system. So struct user interface, like maybe interface system. And we're gonna need to take in context. And that means we're gonna have to have a lifetime here. And then we'll have to implement, so go with some lifetimes here. Implement system for interface system. And here we're gonna have our type, and this is gonna be our system data. And we're gonna set this to, so what do we need for this? I'm thinking, I mean, there's a few things that we need. We need some kind of, we're gonna need our context, we have that. Graphics draw, we're gonna need the frames per second, and I want the number of entities. Those are, I guess those are the things that I really care about. So we can get that. I didn't see a way to have a count of the number of entities that are in the world. So maybe we can just keep track of that manually. So entities count. And this could be a usize. All right, so we initialize that. That's now going to be available to us, but every time that we create an entity, we're going to have to pass that in and update it. So I'm thinking this is an excellent way for us to experiment with resources too. So let's see how we do that. Okay, so in resources, we can roll.insert. It looks like it's going to be a component, except it uses default, which I don't have here. Oh, default is not a specs thing. It's a Rust thing. Okay, so let's create a component, number of entities. So what is this? This is derive, your default, struct, entities, count. And this can just be, I don't think I can just say that that's in like an F32, like it's just a number, or a usize, I guess. It has to be a tuple. So we'll just say usize. All right, so we'll just create a new entities count like that. So when we can, I guess, increment the entities count every single time that we have an entity. This only happens once, so like we don't necessarily want to track you in here anymore. I mean, I guess I could also pass it in, like, so track it outside and pass it in. If I want this to be a resource, I then want, I wonder if like I can now set that. So insert. All right, so world dot insert, and how did that work again? And then you just create it. So this is going to be our entities count, new. Okay, so we have this as our, we're not doing you. Okay, so we have our entities count, and when we draw system, our render system, we can now, I guess we could just draw the interface here. We can now say that we want to read, and read is going to happen differently. So instead of read storage, it's going to be read. Okay, and you will be, nope, there. Okay, so read entities count, like that. Okay, so run, we're going to have a entities count. We don't need to join this because it's just a plain read here. Oh, interface system. I don't think we need that. But now in here, we can create the text for the number of entities that we have, and then we can display that. And that's part of our rendering. So we have function run here. So it has to be inside. Let's go ahead and we'll say let text equals graphics text new. Then we need a fragment, and we can use format, this macro, and we're gonna say, okay, entities, and this will be the entities count .0. Oh, and I think that might be it. And then we have to draw this. So we're gonna graphics draw. All right, so context self.0 is our context. Drawable is going to be the text, and then graphics draw params default, and now our destination. So where are we going to put this? I'm thinking just in the upper left corner. So this can be essentially like, we'll go 10 pixels in, we'll go 10 pixels down. And then I think we have to unwrap this, and then we're good. cannot find value entities count. So render system. Wait, where did I put it? Oh, I put it in the eat system. That's not where I wanted it to go. In the render system, we need entities count like that. That reminds me, I should turn on this. Entities count. In here, we don't have the for loop through it, so now we just have access to it. All right. So this should now tell us how many entities we have on the screen, which means that we need the render system is what we need running here. So let's go ahead and in our not update necessarily, but in draw right now. So mute render system. Okay, so we're running the render system. So let's go ahead and try this out. All right, there we go. In the top left, entities 0. We have no entities on the screen. We also want the frames per second. So I think that we can update that in the inner update. We can like hand the frames per second over. I know like probably the best way to do this would be when we create a render system, I also hand it the frames per second in here. That's something we can definitely do. I wonder also if we can update our what is it called? Update the resource and then have a resource for that too. So let's just try that. Okay, so here's our entities count. If I don't really need to copy you. This is pretty easy. We'll derive default struct. This is FPS. I think it's a usize. No, it's an F32. All right, so I want to return FPS, and 0.0 is our default, like what we're going to start with. And so we'll now insert another one of these. So world.insert FPS new. And so now we have access to FPS. You don't need you. Okay, so using that, we need to update that every single time. So I think we have timer coming in. No, we don't. So let's change that. We need timer. You'll notice that it's like snapping and changing. I figured out how to actually get a cargo format to run every single time I save. So I don't have to run that manually anymore, which is super nice. All right, so on our update for this, let's go ahead and set, I guess before the maintain, we want to now set what this timer is. So it's going to be let's FPS equals, I'm just going to first do this separately. So let's extract them out. It's going to be timer FPS, we hand it the context. I think that's all we need. Yes. Now once we have the FPS, I need to put it inside of, I need to update the, excuse me, sorry about that. I need to now update the resource. This is probably not a good use of resources, but it's an interesting experiment. To update, we need world extension, that mute delta, okay, so equals world write resource. What it is, that gives us a reference to it, which we can dereference and then update. Okay. So let's see. We're gonna say let mute. I mean, I guess in this case, this is gonna be FPS resource equals self.world dot resource, is it resources? Good morning, Katali. Write resource. Is it right? Resource? Yeah, it is. And this can be our FPS, like that. And now we can dereference you, dereference FPS, and set it equal to whatever this is. What are we doing today? Today I am seeing how much I can, how many of these entities I can get on the screen at the same time, and I'm sort of prepping for that. Okay, so set you expected struct FP. Oh, I guess .0. You are type F32 cannot be. Oh, this is a type F64. Also, cannot be dereferenced. Can I instead struct set? So this, apparently this is F64. Okay, so set new FPS. And that's going to be an F64. I don't need to return anything. Instead, what I'm going to do is now we're just going to set. So, oh, we need the mute thing. Okay, so self.0 is equal to new FPS. Okay, so moving back up to update. Now it's going to be FPS resource dot set, and we're just going to set this. Will you be more happy with this? Cannot be dereferenced. Maybe I don't need to. Cannot borrow self.world as mutable because it's also borrowed as immutable. Oh, wait. Mute is our, so self. Interesting. So I don't think I guess I'm borrowing it again as mutable here, but I would think that that ends and like sort of ends the borrow as mutable. Does this need to be like a reference? A mutable reference? Interesting. So I'm not necessarily seeing a good way to update this. Because now it's saying, okay, immutable borrow might be used here when FPS resource is dropped and runs the destructor for type shred world fetch. Oh, okay. So apparently it's handing world into FPS resource when that's not what I'm trying to do at all. But it thinks that there's a possibility that it's going away. Okay. So my initial thought is, well, like I'm not exactly sure how now to like update these resources without doing it in a system. And if I'm going to do it in a system, then I might as well just throw that into here and basically say, okay, render system, and now we're going to also pass it timer FPS context like that. And so if I do that, yep. So we don't need you, which means we're not going to do you. In our render system, we're going to take in F64. And then we're going to, what is that? It's going to be, I guess we just have it now here. So in our text, we can add in more information. So entities, and then we also have, oh, what is it going to be? It's going to be FPS and this is going to be self.1. And so that should draw that out for us. Let's see if we got it right. So there we go. We have a frames per second count. We are currently running at a nice steady like 230 almost. Can you see that? Is this readable as a number? Yep, perfect. All right. So let's go ahead and now create, do we want to create an entity or do we want to also like keep them in? Let's create an entity and we'll put it in the center, just the center of the screen. But we're going to do this dynamically. So in update, before world maintain, I want to now, I guess like every single tick, let's create an entity. So we're going to do world dot create entity dot width, and now this is where we're going to just add in what it has. So it has a location new. I feel like I'm not getting auto completions, so it might be very upset about this. Huh. Because we have a location, right? Oh, it's position. It's not location. It's position new, X and Y. So we need to get the, well, we have the arena size here, so we can just use that. So we're going to say arena size dot 0 divided by 2.0. Okay. Okay, so position with that, then width. We want our size. F32, we can just make this nice and small, maybe like 3.0, and we'll see if that's if that works for us. Dot width. We also have a color, new, red, green, or blue. So I guess for right now, what if I make these all, we could eventually make this random, but 0.0, no, it's 1.0 for white. I'm thinking alpha just slightly less, so like 0.5, and that way our text for like frames per second will pop out a little bit more. Okay. So position, size, and color are all sort of the same here. And they're just sitting here. Then we're gonna have to build. And I think that's it. It's self.world. All right, okay. Now, if I run this, do we get, I mean, it won't look like there's multiple of them, but we should be able to see them piling up. So I see this here, the entities count is not growing. But I see that, I see like the entity down there in the middle of the screen. So that's perfect. So every time that we create one, we need to have now a resource. So we've learned we need to have a resource to increase, like to change the resource. Otherwise, it's not allowing us to have the maintain at the same time. So let's just create a resource for that. Struct increment entity count. Okay. This, I guess we could still have a tuple, but it's going to be pretty simple. We need a write. Just a plain write. And so in here, we're going to say we want a just a write. And this is going to be our entities count is what we want for this. Okay, and then we're going to want our entities count system data. We don't need specs.join because this is just a it's just a write. So we're not going to join this. There's no storage for it really. And I think what we can do is just say entities count dot 0 plus equals to 1. I think that's all we need to do here. Cannot borrow is mutable, so you need to be mutable. Unnecessary parentheses, okay. So increment entity count. So that's gonna be in our update function. So right here, we're gonna say let increment. Did I not put system on it? We need to put system on this. System. Okay, system equals, and you need to be mutable. Okay, so this is gonna be, so it's actually just gonna be increment entities equals this, and then we're gonna say increment entities dot run now, and pass it a reference to self.world, like that. And this will now create, this will now increment that number. So now we should have our entities sort of increasing with that. So we can see how many we're getting. It's a lot. We could also see the frames per second dropping like a rock. Which is interesting because these entities don't have much right now. They're not doing much. I don't know if we like have them do very much also, if that would change anything. We're getting, we have less than 1,000 of them, and our frames per second have dropped down to 9. Okay, so with that, we now want to start moving the entities. We can also like check to see what our frames per second are. I think it's being kept track of already, and so yeah, can I look at the release build? Absolutely, let's do that. So cargo run release, and let's see how many more before. I kind of forgot what that was. What I'm thinking about doing is in our update here, we have this create entity, but I kind of want to wrap this in an if. So if timer FPS hint the context. So if this drops below, or as long as this is greater than 60.0, then let's go ahead and do these. So we'll add as long as we have them greater than 0. Still compiling. I won't hit save yet. You think that spreading them will increase the FPS count? That will be really interesting too, to see if that does. Because I'm planning on having like, it's not just spreading, like we're increasing the number of calculations at the same time. All right. Yeah, building for release is a lot slower, but the code is insanely fast. So I guess while we're waiting, how's everybody week been? I hope it's been good. Hope you're looking forward to the weekend. We running into performance issue with collision detection? No, I don't even have collision detection. It's performance issues with just adding a ton of the entities. I'm also not necessarily doing it in the right way either. I haven't added in any of the optimizations yet, like using dispatcher. What is a ton? I was getting, I dropped below 60 frames per second with like 300 entities. which I should be able to be above 60 frames per second with like thousands of entities, I think. Well, I'm not running the EAT system. I just have it registered. But we can see what we have here. In my update, all I'm doing is I'm creating the entities, and then I'm incrementing the count that I have. And then in graphics, I'm just drawing them out. So graphics, this is like one potential optimization. It's actually creating the entire mesh right here for every single one, every single frame. So if we can put this into a like threads, that would help a lot. This is the system. This is the graphic system. I'm also then drawing out our little interface so we can see how many entities we have count and what our frames per second are. It's so close. We're doing, here we are. Now this is a lot better. Looks like a little bit under 1,500 entities before it dropped below 60 frames per second. But this is the difference between like the release build and just dev build. They're just stationary in the center, yes. All right, so with that being done, I want to save this so that we can now start, we're not gonna create new entities. So if I run this again right now, we're not gonna create new entities unless they were over 60 frames per second. So yeah, so like we got to 118 entities and then we're sort of sticking there. And we're gonna see how we can, that's really interesting. It dropped to 35 frames per second. I think because I'm adding entities so fast that the frames per second calculations weren't keeping up with it. But still, this is a good way for us to like keep track to see, can we increase these numbers? All right. So first thing, let's get them moving. We're gonna need to bring in the random, some random stuff. Let's go ahead. Add another. Well, I'll just add this down here. Use GGEZ rand. Which means we need to use, it's rand prelude star. Yeah, FPS is average over the last 200 frames in the window. So it does lag behind a little bit. Okay, so now that we have this, let's see. We want to now have like a move. We have a velocity, don't we? We have a yeah. So when we create them, we want to have a random velocity that we add in right here. So with size was color dot with not vex storage velocity new, and then this is going to be x and y. So I'm thinking, let's just change this. Instead of a random x and y there, let's see if we can put that in here. So in new, we're not going to take anything in. I might use ran somewhere else. Let's go ahead and we'll create a new RNG here. So let RNG equals rand thread RNG, like that. And then for you, we're gonna have RNG dot gen range. And we want you between, like, let's say negative. I'm not using delta time with the movements, which maybe we should. So I'm going to do between -1 and 1 for right now. We can come back and change this. RNG dot gen range. Like that. Failed to resolve use of undeclared type or module rand. I thought I brought that in. BB rand prelude. Do I also need to bring in? Like that? Apparently. Where's my velocity? Okay, so RNG, you need to be mutable. All right, so this will create sort of a random movement for this. And I think we need a move system now. And that just updates the location. So in our update, we now want to grab the move system. So that move system equals move system new. Nope, just like that. We need this to be mutable. And then we're going to do move system dot run now. Self.world. All right. Do we get them to all just scatter like the wind? They might be moving way too fast too. All right. So we essentially have a we essentially now have ourselves a what is it called? A particle system. It is, however, limiting us, so we're not getting quite as many particles. That also, our entities count is a little bit higher this time. Run it in release. You want to see it in release now too? Okay. So you can see how many, we get thousands of them in release. Now I haven't even done the optimizations yet, but we could also see them like slow down as our frames per second slow down, because we are tied to that right now. All right, that was our limit, 1,525, but we're running at 50, 56, 57 frames per second. Okay, let's now have them bounce off the walls. So that's gonna be another system. And we're gonna need the arena size for this, but we can grab that and then pass that in. So struct bounce off walls system. We're gonna need to pass in the arena size. We don't do that. This is actually, so it's gonna be a tuple, but I think we can just pass it in directly. A resource is how you get delta time into your systems. Yeah, so I saw that. I was having a little bit of trouble of getting the resource in. I have a resource. I'm using that as my entities count, which I'm having to increment that through a system. It wouldn't let me increment it through the way that the book has it. I guess we could do delta time now. So with move. But yeah, so like if I try that again, let's try that again. Here's our default. So if I do struct delta time, this is a duration, I think. What is that? It's a timer duration. No, it's oh, I forget, like, is it standard duration? I don't know where duration comes from. Isn't delta time a float? It is, but I mean, I could do a float, so I can do like an F32 here, and then just convert it over. Okay, so delta time, it's gonna be stored as that. I also need to derive default impl delta time pub function new, and we're going to return delta time with 0.0 in it. Let's register this, or insert it rather. Okay, so we've got a resource in our system, but now we need to update our resource. And I guess I can use it first. So is it our velocity that we do this, or is it our move? I can never remember. I think it's, oh, it's update position. We're basically going to take our velocity and multiply that when we update. So in our move system, now we're going to read, and this is going to be our delta time. Not there, here. So our delta time comes in here. And so position at 0 plus equals velocity.get times delta time. I don't know if this will work. If this will work the way I expect it to. Oh, and it's going to be dt.0. I've got other errors in here. So we're not doing U yet. We're doing delta time. Okay, so no errors so far. Now we need to update the delta time, otherwise it's 0. Nothing will happen properly. So in update, the way that they have this here, and this is what I was having trouble getting to run. We know what our delta time is. I guess I actually, oh, okay, so it's in our move. Where are we running move? Move system, run now. So before this happens, we need to update. We're already using specs world extend, so we need to say let mute delta time equals world self dot world dot write resource delta time, like that. And then we want to say delta time equals delta time, and I don't know if I can like set it. Let's see. Delta time in the tuple here. We now want to go timer duration to f64. D is time duration. Wait a second. Oh, delta, I think. Get the time between the start of the last frame. A convenience function to convert a rust duration type. Okay, so this gives me a duration, and this. Okay, so we're gonna do duration to f64, and then timer delta context. Mismatch types expected. Oh, duration at f6. Okay, that's not what I wanted. Duration f32. Cannot find function. Okay, never mind. So that's not exactly right. Let's try this again. This is gonna be. Wait, do I have a BB function for this? I guess I do. BBGZ. Wait. Oh, timer. Public timer. Probably. Oh, maybe it was under utilities. Utils. No. Are we sure that we created one? I'm not sure that we have one. So we have timer, structs timer. It's like methods, new update, is time up and reset. So that's like a timer for like seconds. And utils is random location. Yeah, we never created that. Okay, so I know, so there's a timer, and we can get delta context. And I think, is there, oh yeah, as sex f32 is actually something from that I can do off of a duration in modern Rust. Okay, so that's what I could do. And we set this. Now here's the problem. Cannot borrow self-world as mutable because it's it's also borrowed as immutable. Line 61, the immutable borrow occurs here. Line 67, the mutable borrow occurs here. So it's worried that the world gets killed the world or the delta time doesn't exist anymore. I think that's what it's like worried about. And so we have a timing issue here. When delta time is dropped, it runs the destructor type, and so it might no longer do that. So the documentation doesn't really have a good system for how you're supposed to do this. So unless you have like a better idea, I'm gonna have to either create a system to update it, or I just pass the delta time in to the move function. Because this is a problem that I don't know how to get around right now. So I'm gonna go ahead and delete all of that. I really do want to do that, but it's just not gonna let me. All right, so I want to go to my delta time and remove you. So in our move system, we're going to take in our delta time, which is an F32. And we don't have to read U anymore. We don't have U anymore. Instead, this is now going to be our self.0 that we're multiplying by. All right. And with that, we want to now actually pass that in. So when we create our move system, where is that? Update. Oh, did I accidentally delete it? I think I did. So move system equals move system, but this now is going to have our timer delta context, do all that stuff, and now we can do our move system that run now self.world. All right, so this is a way. Oh, didn't want to. Cannot borrow move system. Oh, right, mutable. All right, so now they're moving. They're a little bit slow. And we can speed them up by basically making the random generator for our velocity bigger now that we are using delta time. So where's our velocity? Here. So we can do minus 10, 10. All right. There we go for that. That should be good there. And now we want to, I want it to bounce off the walls. So that's going to be another system. So bounce off walls system. We're going to need to, I missed it, was adding the DT resource a success? No, it was not. The problem was that we couldn't, Rust wouldn't let us update the system, like update the resource in the update function due to the world being borrowed as mutable too. And so we ended up getting just an error about that. So I have to pass it in right now, unless like I figure out how to do it, but the documentation is wrong, essentially. Or at least the documentation isn't showing how to do it properly or like where to do it. So we're gonna need an arena size, an F32 and F32. So impl system for bounce off walls. Type system data equals, all right. Here's what we need. We're gonna need our locations. So read storage, its position. Okay. So we need our position. And oh, we're gonna need to write. So write storage, our velocity. Like that. And I think that's all we need. So then we need function run. And so here we're going to have our position and our mutable velocity. We're not going to return that. All right, so you're not unhappy. we need the join for this. So we need use specs join. And now we're going to do our for loop. So for position velocity in, and this is going to be position mute velocity dot join. All right. So now we're going to go through each of these and we're going to determine are they in the arena or not. So I'll just do the center of them because I think that's a little bit easier. We don't have the sizes in here, but that shouldn't be too hard to add in later if we really wanted to. Okay, so if position dot, so let's do the right wall first. So if position dot 0 dot x, if that is greater than, and then it's going to be self dot 0. So the right hand wall. Then what do I want to do? I want to now reverse the x velocity. So we're just going to say velocity dot 0 dot x times equals -1 dot 0. Now, else if position dot 0 dot x is less than 0 dot 0, we're going to do the same thing. Velocity dot 0 dot x times equals -1 dot 0. If position dot 0 dot y is greater than self dot 1, velocity dot 0 dot y times equals -1 dot 0. Else if position dot 0 dot y, if that is less than 0 dot 0, then we want to say velocity dot 0 dot y times equals -1 dot 0. Okay. So that should be that. What are you upset about? No field. Really? How's velocity stored? Oh, okay. So velocity is stored in just here. So I probably want to just do a just make that public. And so this will be velocity dot velocity. Like that. And then I won't need this dot 0. It'll just be the entire like dot x dot y. All right. So this runs the bounce off walls. We should now be able to, in update, get the system for bouncing off walls. So let mute bounce system equals bounce off wall system. We're gonna need the arena size. So that's gonna be the arena size dot 0, arena size dot 1. And then we're gonna run it. All right, let's run this. See how well it works. You know, that's not quite as fast as I was hoping it would be. Let's increase its speed to like, I don't know, 20. We're getting around the same. They're around the same number of entities. and the frame rate per second around 35. One thing I didn't do is resetting the position. And I don't think I can do that because I would need to take the position as right. Well, I guess read it, you could read and write it. So it doesn't look like we're getting anything stuck in the walls too much. Like 1 or 2 up here. I think those are fine for right now. But all right, so we got all these. Let's see. Let's go ahead and make the bounce system work properly. So we need to write storage for this. So you need to be mutable too. The reason why we need to do that is so that way when we reset this, not only are we reversing the velocity, but we're also going to say, okay, position dot 0 dot x. This is the right-hand side. We need to set this equal to, essentially, we need to set it equal to the self.0. But now it's moving backwards, and we're checking if it was greater than that. So I'll go ahead and copy you. This is now going to be equal to 0.0. This is now going to be y. And you are going to be, I guess, self.1. And you are going to be 0.0. Oh, and y. So this should make it so it properly bounces and it'll get stuck in the walls anymore. So I think that'll be good. And now what we want to do is we want to figure out how to make this, like, we want to see if we can get more entities. And I know we can just run in release mode and we get more entities, but we want even more entities in release mode. So we'll see the bounces. I'm going to try, that's the next thing, is dispatch. So let's see if we can use a dispatch system to just, for free, get more entities out of here. So a dispatch system, the idea is that we're going to use threads, but the really cool thing about threads here is we're going to do this every single frame. And so instead of like one thread that we sort of constantly reuse, we're going to spin up threads every frame. They're very short-lived. And then we're going to, in our updates, run those threads. So we don't necessarily, this is happening once. So I don't, well, actually I could increment, like put these into the thread and just have it like constantly add in. I don't know if that will help because this is not happening every single time, but our move system and our bounce system can be threaded here. So let's do this. Let mute dispatcher equals dispatch builder new with, okay, so the system that we want, well, this is going to be our move system. We can now add in our timer. So it's actually just taking this and throwing it in here. The name we're giving this is move and any dependencies. So this has no dependencies. So it's just gonna be an empty array slice. And now we do this again with, and so this is gonna be our bounce off walls. This is named bounce and no dependencies. They can run at the same exact time. Therefore, we don't need you anymore. And so now we need to run the dispatch system, don't we? Yeah, dispatcher.dispatch. So we don't use you anymore. We now do dispatcher.dispatch. self.world. Don't they both write to the same components? Oh, they do, don't they? Move system and oh, they do. Okay, so never mind. Move has to happen first, and then bounce off walls relies on move. So that's our dependency there. Is bounce relies upon move to finish. And we only have a render, like this one render system running here, so I don't think we can put that into the dispatcher and have that automatically run, because dispatcher just throws the entire system into a single thread. It doesn't like spread the system across threads, but that can be later. Let's see if this works. I don't actually have faith that this is gonna give us any extra entities in our system. It's around the same, 110. Our frames per second are just, well, they're about the same. Never mind. So no performance gains then. I think actually we lost some performance. And that's really because we kind of are using threads, but like we're not able to optimally use threads. So I don't think the dispatch system is helpful here unless we had things that didn't rely upon each other. I could add these into the threads and then say like, hey, just create new ones and they could happen whenever, but we're trying not to add them in unless like we have to. Yes, not enough systems. So this is not a good way to do it. So I'm gonna undo this. Okay, so we're back to where we were previously. But something that we can do maybe is look at the structs themselves, the systems, and can I put any of them in threads inside of the system? So in our render system, we need context. I can't put this into a closure because I can't move context in. So this is gonna have to remain out there. Our move system, however, can probably be threaded because they don't care about each other at all. So here's what I'm gonna do. Parallel joins. We're gonna use par join here. Par join, and this is gonna be, I'm gonna essentially have to rewrite this. So we're gonna say for, it's gonna be, we don't even have a for. It's just gonna be, okay, our velocity mute position dot par join dot. Now that gives us an iterator, so we can now for each over this. And now we're going to get our velocity and our position. And now we can do exactly what we have in here. So position dot 0 plus equals velocity dot velocity times self dot 0. I think that can copy in because it's just an F32. And that's it. Now, what are you upset about? No method named for each for type. Hard join, method not found. What am I missing? Oh, I need this. Use rayon prelude. It's gonna be specs rayon prelude star, like that. Closure is expected to take a single two tuple as an argument. Okay, so you are just a tuple, like that. All right, I didn't see that. Okay, so I just parallelized the move system. Let's see if we if this gives us any better, anything better. And our bounce can also be maybe paralyzed, I think. But yeah, no, it definitely can. So we're up to 114. We had like 110 before. So it's like not a huge benefit. And I think that we can now do the same thing to the bounce off walls. Release mode. Let's do bounce off walls and the same way. And then do bounce off walls. Okay, so we need to use specs rayon prelude star. Instead of join, we're going to do par join. So to convert this, we're going to have position velocity. We're just going to have this one dot par join. And then we're going to have a dot for each. Here we're going to have our bar, position velocity, and tuple bar like that. And then what are you? You're this one. So then we need to close you, semicolon. Okay, that should now allow us to run these in threads. Exactly the same number of entities. And our frames per second are around the same. So not a huge difference. And then finally, is there anything else that we can like throw into threads? I don't think so right now. So let's go ahead and run this in release mode, see what we got. And I'm thinking the threads will even get better resources in release mode than we did previously. So we got around 15, a little bit below 1500. Oh, we get a lot more. So we actually lost, we just purely lost performance by doing this. No, actually 1447. It's around the same. If you pull up a CPU performance monitor thing, are my cores being used? Yeah, I don't know. What's the best CPU performance thing besides maybe like top? Do I have one? We've got like a system monitor. Let's see what we got here. Processes. Got this. So CPUs aren't necessarily being fully utilized. You always like HTOP, but Ubuntu should come with one. Yeah, so like this is basically showing like what's happening with the CPU. It's not overly like hitting it too much. But this isn't like, it's not terrible, but I would, we could probably do better. Bottleneck is probably somewhere, I haven't played around with profiling systems for Rust yet, so I'm not sure exactly which ones to sort of like how to look into that. But anyways, I think this is pretty cool. I think this answers a few questions. Like how many entities can we get on the screen? There's one other optimization that we can do that might help out a lot. And so that is going to be, let's bring this back on the screen. Every single frame, and we can't put this into a thread. For this simulation, as is, a GPU could do it really well. Oh yeah, absolutely. I don't know, can I, like, does GGEZ has something where I can just throw things to the GPU? I haven't looked into that before. For my render system, we are having to create the entire mesh here. But what if I held the mesh when I created the entities? So this isn't going into, like, okay, so what if I self-world create entity with position and I just had a with mesh and I created a mesh component. Okay, so if we do struct mesh, and this is going to be a mesh. I guess this is going to be a, oh, it's graphics. That's what it is. Graphics mesh. This is going to be a, oh, the other thing is that we can play with our storage. So we're using vec storage right now, and we might even get better with using dense vec storage. Without paralleling, intuition of mesh is good. Well, it is something that I'm doing every single frame, and I can do that. I could not do that every single frame. Okay, so we want a derive component, and we were using, so I'm going to keep this the same as the other ones for right now. Storage, this is vec storage. So impl for mesh, hub function new. Okay, so what do we need here? We need the context. And we're gonna return mesh. I don't think we need this. After this, you should play around with storage and see, yes, then the next thing is to remove the storage and like try to use the dense vec storage, was the default that it wants to use. I have to be cognizant of time though. I have almost 15 minutes until my stand up. So let's see. Creating a new mesh here. This is, we're just gonna grab you. I'm gonna, well, I'll just copy you for right now so we don't get a bunch of errors, and throw you into here. So we're gonna create our mesh, just graphics, mesh builder new, circle, graphics. So we now need like the size and all this stuff. Let's just make this 1.0. We need like 0.01. From, let's just do 0.0. So like 0.0, 0.0. Color, value, and we can do graphics white, like that. Then we build with context. What are you upset about? Oh, you're new. New, okay, so unwrap. And now we want to say, we're gonna return a mesh with mesh, like that. And that gives us our mesh. So in here, when we create, we're now gonna have to say dot, oh, we have to register that mesh. in our update, we can now say dot with mesh new. I have to pass in context. Okay, so we've got that. We increment entities. And so then when we do our render system, we're now going to read storage, mesh. So we can pull in our mesh. Mesh. And so now you all go away. We just have our graphics draw, and we just pass in a reference to the mesh. Oh, I guess we're gonna be. Let's see, what is it? What are you upset about? Oh, it's gonna be mesh.0. Fine, you're a reference to mesh.0. Got to go fast, yes. Okay, and we need to drop param. The size and the color is fine. What we really need to do here, we don't even need these, which will actually help with our performance. So we're now going to get a .dest, and so here we're going to have to do point to from, and this is going to be our position.0. And so if we don't need size and color anymore, size and color, goes away like that. Let's see what we got in our normal run. $134. So that was a significant increase. These are all like size 1 now. I could make them size 10. I think that would be fine. When I create the component, struct mesh, I'm actually going to leave them at size 10. We don't need to worry about growing or anything. So I don't need to scale them. Oh, they were like size 3, weren't they? Yeah. Not 10. 10 was huge. And so that gives us like 145. That's pretty good. So a few more. I don't necessarily want to try. Well, okay, we try the dense vec storage. That's, I think, the easiest thing. So here we got this. If I select all of these, I'm gonna delete them. We're gonna use the default. We need to bring in dense vec storage by default. We don't need vec storage anymore. Our dispatch builder, we're not really using that. And so we could try this again using dense vec storage, which basically is a little bit more optimal about using the vectors to store everything. It's around the same. I don't think I have enough entities for it to really make a difference here, but it might make a difference in the release mode. I don't think we're going to get over that. Okay, over 1,500? Are we going to get over 2,000? Okay, we didn't quite double, but we got a significant number of entities now on the screen. And they're all moving around. They're all going at. We're keeping close to 60 frames per second. So that's pretty good. Like a little bit of a little tiny bit of work to get the optimizations, a little bit of parallelization. I bet your cores are a lot higher now. It's a good question. Did I close that? I'd close that down. What was that? That was the system monitor. You know, they're still not that high, which leads me to believe that I'm not properly using the memory utilization for ECS very well. So that could be something that we experiment with. But good performance increases, yes. Now, I want to show you something that I sort of got working last night. I've just sort of been playing around with it. So if I switch back to here, I go to code, mine, I was playground specs GGEZ, and I'm just gonna run this, code dot. And let's, I wanna show you what I did. Oh, not code, cargo run. Not even on release mode. So something that I discovered is that I can, using ECS makes it a lot easier for me to like do all sorts of other stuff that I hadn't actually figured out how to properly do before. So I created a camera system using ECS. So I have 4,851 of these dots. And I have a 10,000 by 5,000 pixel world, but it's a 1024 by 768 window, and it's centered on this this single entity right here. Are those entities stationary? Yeah, these are all stationary. This is moving at a very slow rate to the right. So the camera is following the this entity that's moving, and then we can see I've got it set where it's only going to render, like create, and this is not optimized in the same way that we just optimized the other one. I am, for each one of these, creating the mesh at this point, like when it's on the screen, but I'm not even trying to when it's off the screen. So that's why I'm able to get a lot more entities in here. And also they're not moving. But I'm getting a solid like 40 frames per second here. And if I build this in release mode, I'm able to get like over 1,000 frames per second. And in my code here, I'm creating my grid, and I'm saying every 100 pixels, I think I can go down to like 15 before I get, well, I'm getting really serious problems with 15 pixels between each dot. I'm now only at 24 frames per second, but I've got 220,000 entities, 781 in the world, with 3,469 in the page. And if I want to like try to, optimize for this, I think like something like 25 gives me around 60. Yeah, so like 25 pixels between each grid point, essentially, gives me 79,402 entities in the entire world, 1,272 on the screen, and over 60 frames per second. So this is pretty cool. I am using dense vec storage, but I'm not really doing anything with dispatch system, and I'm not doing anything crazy with par, any par joins. I picked up ECS really fast. Well, I mean, I don't know why I picked it up really fast. It just makes a lot of sense. It makes it feel easier to program. Maybe it just works with how my brain works a little bit better. And so I'm looking forward to playing around with this. My next thing before we go into the ecosystem project is I want to try Legion, which is what Amethyst is switching to. And Legion's website claims that it's significantly faster than Specs. So that might be something to try out, just to see if we can get more. But I really want to make a camera system with our ecosystem project, and maybe we'll just follow the biggest one as it goes around. All right, with that, I've got to stand up in 5 minutes, so I'm gonna have to get out of here. But thank you everybody for stopping by and watching. This has been super fun to play around with ECS, with Specs, with Rust, and I'm looking forward to Monday when we try Legion out. With that, have a great weekend, and I'll see you next time.